Okay, so the other SSAI. So there are many people talking about SSAI. There are many SSAI variants around that you might know. And we at Zattoo also care about SSAI since a while. And I want to tell also a story a bit about from the past, what we did there. Quickly to me, I'm Stefan Kaiser, Head of Engineering Director at Zattoo, leading all the video-related teams there, and we implemented our own SSAI solution 10 years ago, and that's why I want to talk about it. And let's go back once upon a time, 2016. So what was the state of 2016? So let's go back a bit. Everyone was still or already talking about SSAI, but in a different way than today. So today we have SGAI, we have SSAI, of course, still in many variants. Back then it was a lot of client-side ads flying around and how to do something with it. But there was a plan to exchange a linear ad break from a linear broadcaster and just exchange it for OTT streams. And we thought, hey, that's super interesting. What else is around? How do you do it? And there is, of course, more to it, to the context of 2016. So we had HLS as a streaming protocol around for Apple devices, maybe for some smart TVs even. And we had Dash starting to ramp up only, and mainly for MSE players back then, maybe a bit of Android already. We talked about Flash. We had the Flash player still around, and we used, in our case, HDS format, streaming format, OTT for it. So there's already the third streaming protocol that you would need to support for an SSAI solution. But maybe you remember the Silverlight player as well. So there's also smooth streaming that you needed for Silverlight, for Windows native apps, for Xbox, and so on. So a whole different ecosystem than we have today for OTT streaming. And in addition to that, there was maybe two variants already being discussed for server-side ad insertion, how to do it. The classic one that everyone knows today is manifest manipulation, of course. Multi-period dash, basically. On the HLS variant with discontinuities, always worked, still works fine. But the Dash case might be the problem because Dash wasn't supported too much, as we know. It's 2016, it's only MSE players, and even they had more or less only demos. If you walk to the IBC, everyone had a demo about SSAI, but no one really implemented it on a production scale, at least in Europe. I think in the US it was a bit different back then already, but in Europe, not. So we thought, hey, it's not that hard. It sounds super easy. You have a linear signal, and that comes even with markers that tell you where's the ad. So just go there, use the marker, fetch some ads from an ad server, and exchange it in the stream. You get a personalized stream for every user. As your OTT, you can do it, and then earn some money, basically. Everyone earns some money. It's a win-win thing with SSAI in the end. So we thought, hey, let's do it. And we started with it and thought now, after 10 years, was it really that easy? So let's have a look. How to implement it. We talked about it. Client-side ways are possible, server-side ways are possible. Due to the low adoption rate from multi-period yet, that wasn't possible, we choose a different server-side ad insertion variant, which is fragment stitching. So we actually went below the streaming protocol and exchanged frame by frame from the original content to the advertisement content. And in our case, we were lucky enough with our current architecture that we had on-the-fly packaging in place already. So it made it easy for us, as anyway everything was packaged freshly for every user. We could basically decouple the cache request from the SSI things. So SSI wasn't a cache request. Basically, it was always resolving the ads first and trying to get an ad break in for every user. We could do it because we have an intermediate format before our packager. That was, we call that the provider component, basically requesting from upstream transcoders whatever you need on content. And there we placed our stitching logic. So, so far, so good on how we did it. So we implemented that, started implementing, did everything how we thought it's good, and then we tested it. And then, of course, there are those markers that everyone loves. SCTE markers are the best. I don't know how it is in the US with the markers. You have them basically more time than we in Europe, because back then, 2016, we had to convince broadcasters to actually integrate markers, SCTE markers, into their signal. They didn't have that. They didn't even have the hardware to do it, basically. So step by step, we got a broadcaster and another one to integrate something. But what about the accuracy of those markers? Are they good or not? So we implemented our solution, then we tested it and thought, hey, our stitcher is always, it's a bit off, basically. Sometimes it's too early, sometimes it's too late. So we checked our solution, if we have a bug in it, because I mean, it's super complex to resolve all ads and so on. There might be a bug, but it was perfect, of course. So we went further back and checked the signals, which is super annoying because you need to pass the SCTE marker, you get out the PTS timestamp, then you need to hopefully record your source signal, find a corresponding frame, match it basically, and then see if that is really the first frame of the advertisement break. Okay, so we did that. Manually once, and then we thought, hey, maybe that comes up more often, and we figured out it's off, basically. And so you can talk to the broadcaster if they fix it, or you can, if you're lucky, you have a fixed offset, and you can work it in somehow. We created a small tool, but I think the video is not working, so I added a static slide that we could configure our interest component, which creates a square, red square, on exactly that frame where the SCTE marker is pointing to. So the person configuring our interests could easily verify, hey, is it off, is it not off, and maybe do some offsets into the configuration, or directly go back to the broadcaster. So that's how we fix it. Still manual effort needed for the interest setup, but fair enough for us to move on. What else? So we have the markers now. We have exchanged the ad break, and then we play our stream. The source signal is basically, okay, so animations don't work, obviously. So we are already on the third part of this slide, but we have the blue part is the original content. We run into the ad content. There are GOP structures in it, of course. And we end with the ad GOP structure, and we come back into the source content. What might happen there? Visually, there are decoder artifacts popping up suddenly, something is wrong. So pretty clear in that room, I guess everyone is spotting the problem. We are not entering on an iframe here. So decoder problem, fair enough for the decoder, he's right, all good. So we had to get in a keyframe at that specific point in time to make the stream valid. Luckily, again, with our current architecture, we had also not only on-the-fly packaging, we also had on-the-fly transcoding in place. So easy enough, we just extend our transcoding API and add a keyframe parameter, so it always triggers a new transcode and creates the keyframe at the right spot, and with that we could move on. Maybe you're wondering if that adds transcoder load. Yes, it does. But it was fine, so we could deal with it. But looking at it, of course, we figured something else out. We figured out that all ad content was transcoded every time it was requested freshly. And we're wondering why, but was also pretty clear when looking at the implementation, because it went through our VOD encoding pipeline. Because in fact it's basically a VOD asset, so that lower frame rate than our linear signals, which all target 50 frames per second. So it always re-encoded the ads to match the 50 frames linear with 50 frames ads. Easy fix for that. We just assign a different profile for the ads ingest pipeline, basically. So what else? Sound check. So we have the video flowing now, well enough. No artifacts anymore, no other problems on video. But sometimes users complained that there's no sound during the ad break. And we were wondering, hey, why? We are testing it. It works on a laptop. You're just testing with the ad break. No problem, I have sound on the exact same part where the user had a problem. So we dig deeper into logs. What is the user actually requesting? And it turned out it was one of the channels or the really signals that had a Dolby track. And that user had a Dolby setup and was selecting the Dolby track, which advertisement typically doesn't have. So for some reason, they don't spend the money on creating advertisement in Dolby, which meant for us, there was no Dolby, no Dolby track, and there was no audio content, basically. So for that, not so easy, but still manageable. We just upmix the stereo content from all ads and force it in the ads ingest pipeline. And then you have an upmixed Dolby, which means you can still listen to something on ads. What else? Audio is always the fun thing. We love video, of course, but then we run into audio problems in video technology. Maybe you see what's coming. So ads are also typically too loud. Everyone knows it, everyone hates it. Of course, that's the case here as well. So we had ads that are too loud. People were complaining. So we apply loudness normalization. Yeah, easy, you think. But loudness normalization on small files, 20 to 30 seconds, basically, isn't that easy. In the linear signal, it's fine. It's initializing once, and then it's just continuing. But here, it needs to ramp up every time at the beginning of the file. And that means it takes 2 to 3 seconds until the loud norm logic really kicks in. So we had a spike every ad start, and then it went down again. So what did we do here? We just copied a bit of audio content, pre-pended it in the front, then ran it through the loud norm, and then cut it again to use it. And with that, we could make it work. So that basically made the whole solution work. It's much more complex, of course. There are many more things that we could talk about, but for the 15 minutes talk, I think that's fine enough. Would we build it the same way again today? Probably not, because there's manifest manipulation supported everywhere. So it's fair enough to use that, makes sense, and so on. But interestingly enough, all those problems here would also apply to manifest manipulation to everything in the end, to all the server-side ad insertion, maybe to client-side ad insertion even. So problems that concern everyone. But with that, as it's 2026, happy birthday to the Zattoo SSAI solution, 10th anniversary. Thank you.